Hello, welcome to video series part 2. If you missed video series part 1, you can click the link below to watch that first. Okay, so video series part 2, we're going to talk about the 6 predictors for long-term success. Where did this even come from? Well, this was a research framework. A couple colleagues and I were asked to focus on early childhood. What questions would we ask young kids? What math topics, activities would we give them that would predict long-term success? So we spent a year just reading articles and trying to understand what's happening and what should we focus on. And it came down to these 6 components that are these 6 dimensions that really predicted long-term success. So there's certain things like probability, coins, things like that didn't make the list, but these 6 did. And I'm going to do them in reverse order. I'm going to end with the 2 most powerful ones. And this is kind of interesting if you're thinking about, what would these be? The first one, number facts. So a lot of people think number facts is the best predictor. It does predict. However, just knowing your facts, it's one of these topics that's in your brain, but only in one area. It doesn't connect with a lot of other things. So knowing the facts is important, but then how do you apply them and use them is very critical, and that comes in later. So just knowing facts, great. Second predictor is sequencing. It's counting forward, counting back, skip counting forward, and as I was saying, back. That is the most important. We found that, hey kids, can you count to 100? That's important, but part of that's memorization. It's part of your executive function. However, counting backwards gives you a lot more information. So especially like when you're at 92. Keep counting backwards, kids. 92, 91, 90. You hit that decade. What do you do next? Do you go to 89 or do you start counting back up? A lot of kids start counting back up. So looking for that. So that's a really good predictor. Third one is context, story problems, context. So Carpenter and Fenema did a lot of work on cognitive guided instruction. And going back to that work, they talk about there's 4 types of story problems. There's join and separate, where these problems in stories. I'll give you an example. So there's 3 birds on a limb and 2 more birds join. So land on the limb. So there's that joining process. Now there's 5 birds on the limb. You could say, those 5 birds, now 1 flew away. So that's separating. How many birds are still there? Then the 2 harder problems, comparing. There might be 3 blue birds and 2 red birds. How many more red birds are there than blue birds? So now we have that comparison. Or there's just blue and red birds, and now it's a part whole problem. So you're trying to look at that relationship. And then of course, with any of those 4 types of problems, where the unknown is at the beginning of the problem, the middle change part, or the end result can change how difficult it is. So the compare and part whole problems were the ones that were really more telling of kids' weaknesses or strengths within the mathematics. The 4th one is relational thinking. Some people think about this as like number sense. Maybe it is, but looking at relationships. So we want to be able to, focusing on the equal signs. That's why the equal sign becomes really important in looking at those relationships. And so it could be things like 17 plus 6 is equal to something plus 7. So instead of solving all that here, like algebraically, can you just look at the relationships of that 17 in the blank and then the 6 and the 7? The 7 is 1 greater, which means this one should be 1 less. So kids being able to look at those relationships becomes really a good predictor of long-term success. Okay, those are the first 4. They're all really important. These last 2 were the most powerful. Measurement. A lot of people would not guess this. Measurement. In fact, our colleagues, after we read all this work, and even as we were testing kids, working with them, doing research, we were still like, why is measurement such a good predictor? And that's when we found out that when you're measuring, you have to figure out, like, what is the unit? So are we talking about temperature? Are we talking about altitude? Are we talking about number? What are we even talking about? So we have to focus on what that unit is, and then take that unit. We typically iterate it or partition it. So we're going to copy that unit over and over again. So we might be talking feet. Okay, so then every 3 feet becomes a yard. So we can continue counting in feet. We can convert to yards. We can take a mile and then partition that. So there's all kinds of things where if you were watching series number 1, we talked about the structure, the words, the structural language, which is so important. That's where this starts coming from, is like, the equal sign is really important, relational thinking. And then it's, this idea of iterating and partitioning is really important, and focusing on the unit. We have to know what we're talking about. It actually leads into other things that I find really neat, like fractions. So we talk about you can only add, subtract like denominators. Well, those are really, it's like units. We only put units that are the same together. And so the like units makes a lot of sense. And then we say it's like denominators. I was an algebra teacher, and it was the same thing. You only put like terms together. Well, those are similar units. So like an x squared unit can be with other x squared units, but not with an x unit or a number unit. They have to stay separated. So really important ideas there within measurement, and why it's one of the better predictors. So getting kids to do this idea with measurement early. And now another thing, we're going to highlight this in another video series in greater detail, but the number line. So the measurement is really thinking initially, when we're thinking linear measurement, I'm not talking area and volume and some other things too. However, just that linear measurement you start building early in the career is the number line. And that becomes really important in those early grades and extending it all the way through. So having students get that, having a just imagined number line in their head becomes really critical for success. Now the sixth one, the best predictor, is part of geometry, and it's spatial reasoning. A lot of people think, oh my gosh, spatial reasoning, like packing your trunk, packing a suitcase. Oh my gosh, how do we get all these things in that one space? I'm not good at that. Puzzles. And okay, first thing is that spatial reasoning can be learned, absolutely. And why is it so important? Again, that one took us a while to figure it out. And when you do spatial reasoning, whether it's 2 dimensions, 3 dimensions, you are decomposing, you're breaking things apart, and then you're recomposing them in different ways. And we're like, oh my goodness. All of our algorithms, our properties, they are all focused on decomposing. So even thinking about like our addition, like our algorithm, we line it up vertically, we focus on just the ones. If we have more than 9 ones, then we have that 10 over here. So we're decomposing it by each place value unit and then recomposing it. Really important. Associative property, 3 plus 4 plus 5. Yep, we can add the 3 plus 4, the 4 plus 5, it doesn't matter. All those, and why would we do that? Well, it's things like becoming fluent. It's like 17 plus 8. For me to think about 17 plus 8, I'm going to decompose that 8 into a 3 and a 5. And then I'm going to recompose it, social property. 17 plus 3 is 20, plus 5 is 25. Much faster. So I can, as I'm working on problems in different situations in real life, watching sports, whatever, that's one of my main strategies. So another key idea here is, so that spatial reason, we're thinking of visual representation. So a lot of times we're looking at a bar model, so a rectangle representing quantity. And that's important to have a proportional size where that makes sense. And people who've done a great job with that, Singapore, they have a book called The Model Method. That's a great book that talks about how is a bar model, that visual representation, implemented starting in kindergarten all the way through Algebra 1. So it's maybe less than 100 pages, but it gives you a real good idea of these different problems and how to use that. Now this connects back again to video series part 1, when we're talking about Jerome Bruner saying that when you model a problem, you do it in active physical model, you do the visual iconic model, and then the symbolic model. The visual model, so your ability to see the mathematics, either through that number line, that bar model, that's the critical piece in making sure you understand it long term. So if we're focusing just on practicing a certain tool or an algorithm, so often that a month from now, let's be honest, let alone a year from now, kids are saying, I have no idea what you're saying. I've never seen that in my life. And even if you were the teacher, you're like, no, you saw this. We spent 6 weeks on this. But there's no connection. So being able to have that visual representation and then connect it also to a context situation, which is one of these predictors, then you have that power of truly getting kids to understand it for a long period of time. That's what makes these 6 predictors so important. Now that we're at the end of this video series, part 2 on the 6 predictors, I'm going to check some of the questions and try to respond to them as well as I can. Okay, the first question is on mad minutes, facts, practicing for fluency, and should we stop doing that? That's absolutely, I love that question. I should have started with that. I'm saying that the facts is a predictor, not maybe one of the best predictors. However, it is so important for us to know facts. Absolutely. And we're going to have another video series later that talks about how to become fluent and how to actually keep addition, subtraction, multiplication, and division facts in our head so we can actually use them in school and outside school. Okay, question number 2 here is talking about measurement. Measurement's not one of those big areas within schools, and how do we combine that? Oh, I love that question. Yes, it was somewhere around the 1970s. Curriculum made a lot of different changes, and they pulled a lot of the geometry and measurement that was really kind of sprinkled out through the curriculum pre-1970 and put them at the very end, thinking that we could jump forward, moving on number issues more quickly. And what we found is, that was measurement, geometry, spatial reasoning especially, need to be incorporated throughout the year. So part of what we've done to help with that process is just including things like the number line, the bar model as these visuals and these measurement ideas, and embedding those in the models, and then the language really helps understand and solidify number. Great question. Okay, this question talks about teachers are always pressed for time. Absolutely. And how can we use these 6 predictors in the curriculum? That's a great idea. I think we've kind of used that as two different directions. One, how do we use the models and language and incorporate those? Which models? That's going to be another video series. Which tools are better to hit these ideas, and which tools do we typically see in classrooms that don't really help that? Because we want the tools that are most powerful that we can incorporate now, and that they are going to be used to build knowledge of the mathematics all the way up into Algebra 1. So we want that to be a very fluid process. So we help with that. And then 2, we have a lot of supplemental activities that we've built, some target activities, different intervention worksheets that teachers can use to help build that if kids are really struggling in those different areas. Last question is, so does DMTI include, do we have different types of resources? Yes, we have lots of different resources. We actually have screeners and diagnostics. That would be another web series to get that in more detail, but they come from the research, and they've been validated. And they connect these 2 targeted activities specifically that where kids are struggling in these different areas. There's very specific individual or small group activities to get them to build those ideas. There's that. Plus we also have some different apps, some games, and then we have different units that could be used to supplement, or we have all year curriculum as well. So we've incorporated them in very different components that hopefully you can use for whether it's diagnostic, target activities, small group, intervention, or core resources. I know you're finding this information very interesting, because after doing research on this, I still find it absolutely amazing. So click the button below and we can help you implement these ideas into your school right now. You can read about this in our research overview, get some more details, and stay tuned for part 3 video series.